Now we'll see some more gate questions related to this, pipelining. The question is asked in gate 2 on paper, this question. An instruction pipeline has 5 stages where each stage takes 2 nanoseconds. So pipeline has 5 stages like this, 1, 2, 3, 4, 5. So stage delay is 2 nanosecond. Assume that let's say each stage takes 1 clock cycle. Now the next line is branch instructions are not overlapped. Before that one more statement is there, you see. All instructions use all 5 stages. See, we know that, right? Generally it happens. Branch instructions are not overlapped. That is, the instruction after the branch is not fetched till the branch instruction is not completed. Under ideal conditions, try to understand it. Whenever there is a branch instruction, assume that this is a branch instruction, then the next instruction is not fetched until this instruction is completed. So that means what? This instruction is not allowing sharing. It is, using all the resources exclusively, I can say, all the stages exclusively. That means Mr. Branch instruction, that means you don't allow the, sharing, right? Yes. Then how much time you require? 10 nanosecond. That means, so each branch instruction is going to have a penalty of 10 nanosecond, right? If the instruction is not branch, any such instruction is allowing sharing, correct? So we can happily, because next instruction starts here, then these instructions all the time, whatever the time this instruction is taking, that will come under this, this instructions execution time. See one more time. Example, if this is not a branch instruction, then what is going to happen is, so there are 5 stages, right? Let me show here only 5. So what I am saying is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if you see these two overlapping instructions, then the time taken for this instruction is not separate 10 nanosecond. It is only 2 nanosecond extra, right? Because remaining all 8 nanoseconds are accounted in this calculation or this, instruction, I can say. Because when you count this instruction's execution time, then you don't require to count the execution time of this one. Similarly, next instruction also will be overlapped under this instruction. Then I can say finally no instruction requires 10 nanosecond. Every other instruction takes only 2 nanosecond. We know that, correct? See here. This instruction takes 10 nanosecond. Apart from that, all other instructions require only 2 nanosecond. If I ignore this, this only instruction, then in the long run, then all the instructions I can say takes definitely 2 nanosecond, right? So that's fine. So let us summarize. What I want to say is there are 2 kinds of instructions, branch and non-branch. Every branch instruction requires definitely all the cycles because no overlapping. So it requires 10 nanosecond. Apart from that, if you have an instruction which is allowing the overlapping, then we know the story. For such kind of things, then we require effectively only 2 nanosecond to execute. Then you might have this doubt, sir, this instruction is taking again 10 nanosecond, right? Yes, only the first such instruction takes 10 nanosecond, but all the remaining instructions, they only take 2 extra nanosecond. That means on average, otherwise if I ignore the first fact, then every instruction takes only 1 stage delay. We know that, right? So 2 nanosecond. Because the question is not about a particular 50 instructions or 30 instructions. This question is about, some set of instructions. Let's take very big number of instructions. If you take 100 instructions or 1000 instructions, then if the instruction is branch instruction, definitely there is a 10 nanosecond delay for every such branch instruction. But if the instruction is non-branch, it is allowing the sharing so every non-branch instruction effectively is taking only 2 nanosecond except the first one. Understand? So they are very rare, right? Now we'll see the formula to calculate. We'll see this question. Calculate the average instruction execution time assuming that 20% of all instructions executed are branch instructions. Ignore the fact that some of the branch instructions may be conditional. Okay, we'll ignore. He's saying that some branch instructions are conditional. Okay, there is a condition, not a problem. However, whatever may be the branch instruction, we will not be fetching the instruction immediately, right? Whenever you have a branch instruction, after completing it only, we are fetching the next instruction. If that is the case, then what is the average instruction execution time? For that, formula will be like this, you see. Just divide the instructions into two parts. So 80% of the instructions are non-branch, 20% of instructions are branch, right? So this 80% instructions, I can say, definitely can share the resources, then on average they only take 2 nanosecond of time, correct, because they can be executed parallelly. But there are 20% of the instructions they want exclusively, I mean they don't want to share and they want all the resources. That's why 20% of the instructions are going to use all the 10 and all that 5 stages exclusively, so no overlapping. Then every such instruction requires 5 stages, so 10 nanosecond. See, because of sharing only 2 nanosecond for non-branch, here 10 nanosecond, that's it. So if you simplify it, 82 is a 160 nanoseconds by 100 plus 20% into 10, 20 into 10, 200 by 100. So if you simplify, it's again nanosecond. It would be 360 nanosecond for 100. So it would become 3.6 nanosecond. In that way, so we can solve this problem. 80% pipelining, 20% non-pipelining. Understand? So one more way we can solve this problem, that is, you see, because sometimes that formula might be helpful. Whenever you have a instruction, if it is branch instruction, then it is, if it is branch instruction, then you are starting here, right? Actually you supposed to start here, but even you did not start here, you did not start here, you did not start here. So it is stopping the pipeline for 4 stalls, I can say, correct? So there are 4 stall cycles. Understand? So now we can solve this problem like this. There are 20% of such instructions which are creating 4 stall cycles, correct? Now I can say that. So actually generally every instruction requires only 2 nanosecond, but if there is no stall cycle, right? If no stall cycles, then everything will go full-fledged, full pipelining, then answer is 2 nanosecond, right? We know that. But we need, because of this 20% additional instructions, they are going to create a penalty. So Mr. Branch instruction, how much extra penalty? This is extra penalty, you see. How much extra penalty you are having? 4 stall cycles. Try to understand. These 1, 2, 3, 4 are extra for this branch instructions. Apart from that, they are also creating 2 nanosecond delay. Understand? So I can say that everyone will create 2 nanosecond delay, but apart from that, these branch instructions which are 20% will create extra delay, which is nothing but 4 stall cycles. 4 into stall cycle value, stall means 1 stage delay, right? Each stall cycle is for 1 stage delay. 1 stage delay is 2 nanosecond, correct? So I can say that 2 nanosecond plus 20% of 8 nanosecond. If you simplify it, you get 2 nanosecond plus 28 is a 160 by 100 nanosecond, right? Same thing, you get 1.6 here, 2 nanosecond plus 1.6 nanosecond, 3.6 nanosecond. So this is the way we can solve this question. Okay, there are 2 ways. Now let me summarize the second way. The second way is like this. If there is no stall cycle, answer is 2 nanosecond generally, correct? But because of stall cycles, the additional delay will be caused. That additional delay is 4 stall cycles. That means 4 into stall cycle value is 2 nanosecond. But how many times? 20% of the time, correct? Not every time, only 20%. This is the way we can solve this problem. You get 3.6, right? Now there is another question, B question. We'll see that. See this question B. If a branch instruction is a conditional branch instruction, he is exploring the branch instructions. In the previous problem, he simply said, branch instructions. Every branch instructions property was same. This time he is exploring the branch instructions. We will try to understand. If a branch instruction is a conditional branch instruction, then the branch need not be taken. Yes, we know that, right? If the branch is conditional, then branch need not be always taken. Sometimes it may be taken, sometimes may not be taken. So now, if the branch is not taken, what happens he's telling. So finally you have branch instruction, right? That conditional branch instruction. At that time, so condition may be true and branch may be taken, branch may not be taken. There are two cases he's explaining us. Fine. So what if branch is taken? He's telling. What if branch is not taken? First he is starting with branch is not taken. If branch is not taken, the following instructions can be overlapped. So he is saying that if branch is not taken, then we can overlap the instructions. Like, just normal. Did you remember? If there is no branch instruction, generally what we do in the pipeline, we overlap the instructions. So similarly, though it is a conditional branch instruction, if condition is not taken, then we can overlap the instructions. That means what? So generally in our discussions, what we did like this. Simply we fetch, decode, execute, memory, write back, right? If it is branch instruction, but still we fetch the next instruction. Generally in static pipelining model, I simply fetch and decode. So after some time I realize that branch is taken. If branch is taken, I flush it out, all this stuff, correct? So then why are you, sir, fetching the next instruction, sir? Sometimes if branch is not taken, then we supposed to start with next instruction only. Then if I prefetch it, that means immediately I fetch the next instruction with the local knowledge I have. Then sometimes what happens, so it might be helpful for you. That means full overlapping is possible, right? So that is what we are doing. I will give you one analogy. Example, let's say, so your mom asked you to bring, she gave you 5 rupees and she asked you to bring coffee packet, otherwise tea packet. Okay. She ordered you to bring coffee packet or tea packet, but what happened? Something she said you, right? But you have forgotten what is that, whether it is coffee or tea packet. You went to that shop and after that you have forgotten. But you know one thing, she gave you 5 rupees and in the shop there are only two things. One is coffee packet and one is tea packet, and it's early morning and you know that every day morning in your house you drink either coffee or tea, but you don't know exactly what today you have to bring. Then you do one thing, you just take coffee packet and go. Then really after going home, if your mom says, yes, I asked you to bring coffee packet, then we can save the time, right? If your mom says, no, I asked you to bring tea packet, then we can again go to the shop. The exactly same thing we are doing here. What he is saying is in the question, so if the instruction is branch instruction and if condition is not taken, that means branch is not taken, then by that time if you start already fetching the next instruction, then overlapping is possible, right? So he is finally saying that if branch is not taken, simply overlapping is possible. Now let us continue reading. The following instructions can be overlapped. Next, when 80% of all branch instructions are conditional branch instructions. Now he is explaining the statistics. We know that already this is linked question. We know that in the instructions, whatever the instructions you have, how many are general instructions? 80%. We know that, right? Let us list out. Out of 20%, out of that 100, 20% are branch instructions. Let me tag them like this. Okay. The label is branch here. So in that branch instructions, now the remaining story. What is that? When 80% of all branch instructions are conditional branch, that means already we know that 20% only are branch. Out of them, he is saying that 80% of all are conditional branch instructions. Okay. Now that means what? So let me write. These are all conditional branch instructions. So, but total should be tallied to 100, right? In the 20, 80 are conditional branch, remaining 20% are unconditional. Okay, right? Unconditional. Now let me make everything clear. In the first problem we solve like this. Instructions 80% normal, 20% branch. But further we did not explore, because for every such branch instruction story was same. Now story is different. What is that? Out of 20, 80% are conditional, 20% are unconditional. Sir, what is the meaning of unconditional in branch instruction like this? Jump to a memory address 200. Whenever you execute this instruction, always we have to go to 200, right? It's not, there is no condition. We should go to 200 always. Now what is conditional instruction? Like branch R1, R2, we have seen conditional instructions. There will be a condition, then condition is true, then we will jump. That means we will go to the target address, otherwise not. So such conditional branch instructions are 80%. Now let me continue reading. 80% of all branch instructions are conditional branch instructions, and 50% of the conditional branch instructions are such that branch is taken. In the 80%, 50% of the instructions for that branch is taken. Okay, that means what? Remaining 50%, use common sense please. Not taken, correct? Because either branch will be taken, otherwise will not be taken. But in the problem he said that 50% conditional branch instructions are such a way that they are taking the branch, then remaining 50% are not taking. Sir, why are you writing all these things? Because our problem depends on them, you see. Now after that, anything is given, 50% of the conditional branch instructions are such that branch is taken. So 50% are not taken. Calculate the average instruction execution time. Now we have to find out the average instruction execution time. If there is no branch instruction, what is the average instruction execution time? 2 nanosecond. Because so only one stage delay, right? We know the stuff, right? So only just one stage delay is occurred. But now these instructions are taking lot of stalls. Otherwise, these instructions are not overlapping sometimes. That's why they will have additional penalty. That's why let's systematically solve this problem. So what we do is we take every category, and for every category we'll ask that instruction how much penalty you will have. Okay. Now out of instructions, 80% are non-branch. First of all, let us focus on non-branch instructions. If the instruction is not at all a branch instruction, then we will be happy. For them, 80% of the instructions are having, what is the, execution time of that? Because we are calculating average, then take example, let's say you have 5 boys, 2 girls, okay. Each boy has age 10, each girl has age 12, then what is the average? For that, how you solve it? 5 into 10. Calculate all the age of boys plus calculate all the age of girls. 12 into 2, 24. After that, number of boys and girls. How many? 7. This is the way we solve it, right? In the same way, here also what we are doing is, for every type of instructions we are calculating instruction execution time. 80% of the instructions are taking only 2 nanosecond, right? That's it. Plus, so 80% of the time penalty 2 nanosecond. I can say penalty also, right? Now remaining 20%, because see this is 20%. These 20% out of 20%, not all are having same uniform penalty. Let us focus on this one. On the 20%, on the 20, 80%, on that 80%, 50%. I can say that on 20%, among the 20%, 80%, among this 80%, 50%. So this category is what? There are, some instructions with this, probability 20% into 80% and 50%. For these many instructions, what is the penalty? First of all, we'll see the category. This is an instruction where it is a conditional branch, but where branch is taken. If branch is taken, we can't take any help, because already we know that in the problem it is given that if branch is taken, then we have to wait, correct? Then the next instruction starts from after completion of this one. That means what? All these instructions are like branch instruction with full penalty. So that's why how much penalty they will have? All these will have 5 stage delay, because they are not allowing the overlapping. That's it. These instructions are branch instructions and they are not allowing the overlapping, because there where condition branch is taken. When branch is taken, in the problem clearly mentioned that we cannot overlap it, then they require special 5 stage delay, that means 10 nanosecond. Now try to understand. All these instructions require 10 nanosecond. How many? 20% on that 80% on that 50%. Now let us take the third case. See, this case is done. Let me mark it. Now in this case, this case is done. Now in this case, not taken. How many such instructions are there? With probability or with possibility? 20% on that 20%, on that 20%, 80%, on that 80%, 50%. these many instructions are classified as not taken. That means branch instructions where branch is not taken. When branch is not taken, already I told you in the problem also they clearly mentioned no penalty, because overlapping is possible. If overlapping is possible, then the instructions are this kind of instructions. How much penalty they have? 2 nanosecond. Okay, plus now come to this case. What is that? This case is covered, this case is covered. Now we'll go back. So now this is the remaining case. What is that? Branch instruction but unconditional branch. How many such unconditional branch instructions are there? 20% of, see, 20% of 20%, correct? So 20% of 20% are unconditional. For unconditional, definitely branch is taken. So how much time they will take? We'll ask, my dear unconditional statement, you always take branch, right? Yes. That means we can't escape the penalty? No, you can't, because overlapping is not possible. That means they need special 10 nanosecond. That's why 10 nanosecond. That's it. Take every classification and identify the penalty. Now if you simplify it, what are you going to get? You see, 80% of 2 nanosecond. Okay, so if I simplify it, 0 0 cancel, 8 to the 16, 16 by 10, 1.6, 1.6 nanosecond, done. Now second case, see, 0 0 cancel, this 0 cancel, this 0 cancel, 5 to the 10 and this 10 cancel, then you have 8 by 100 into 10, right? This 10 and this 0 cancel, then you get 8 by 10, which is nothing but 0.8 nanosecond. Now the third case, 20% of 80% of 50%. Let us cancel zeros. 0 0 cancel, 0 cancel, 0 cancel. Now see, 2 5s are 10 cancel. Now remaining thing, 8 2s are 16, 16 by 100. 16 by 100 is 0.16 nanosecond, right? Everything is in nanoseconds. Now the last one, 20%, 0 cancel, 0 cancel, 0 cancel. You have 2 by 10 nanosecond, 0.2 nanosecond, right? Now let us simplify. If you simplify, 1.6 plus 0.8, 2.4, 2.4 plus 0.2, right? It would be, I think it is 20% of 20%. We have two 2's, right? Two 2's are 4. So here you see one more time, 2 2's are 4, 4 by 10, 0.4 actually, right? Now if you simplify it, 1.6 plus 0.4, 2 plus 0.8, 2.8 plus 0.16, which is nothing but 2.96 nanosecond. In that way, easily we can solve this question. You should understand the concept, that's it. Okay, now this model is very important. We will be using this kind of model in memory also. That's why try to practice it. Okay, so try to understand, do research. Okay, at a time you might not understand. If you don't understand it, then focus it, try to understand it again and again. Okay, so this is all about aptitude. See this question, a CPU has a 5-stage pipeline and runs at 1 gigahertz frequency. What does it mean, 1 gigahertz frequency? Actually that is called clock rate. Okay, so the relation between clock rate and clock cycle time we'll see. Generally, one clock cycle time, if you want to find out in your computer, that is exactly equal to 1 by clock rate. Okay, this is the formula. So here 1 by clock rate is nothing but 1 gigahertz. Giga means 10 to the power of 9, hertz means 1 by second. So it is second inverse. If it goes up, it will become second. So answer is, that's why in the seconds. And 1 by 10 power 9, which is nothing but 10 power minus 9. So 10 power minus 9 seconds. So finally we got clock cycle time, which is nanosecond, right? Clock cycle time. 10 power minus 9 means 1 nano, right? 1 nanosecond. Remember it. Now read the remaining question. What is that? Instruction fetch happens in the first stage of the pipeline. We know that. A conditional branch instruction computes the target address and evaluates the condition in the third stage. He is telling that there are 5 stages, and if it is conditional instruction, then the instruction execution will be here. He is clearly mentioning that in the third stage, so that target will be calculated. Target address and computes the target address and evaluates the condition in the third stage. Fine, this is third stage. That means after the third stage we will get the target address. Now remaining question, the processor stops fetching new instructions following a conditional branch until the branch outcome is known. See, branch outcome is known here, then by that time we are not fetching any new instruction, so freshly we are starting the fetching. So remaining details are unnecessary, sir. How such things will be implemented doesn't matter for us. So fetch, decode, execute, in that way it will start again. So what I want to say is, generally if this is not conditional instruction, then we would have had like this, right? Then we would have had overlapping. When you have overlapping, then I can say that each instruction is effectively taking only one clock cycle time, correct? Otherwise one stage delay, correct? We know that. Let me emphasize this point. What is that is, if your pipeline goes in full-fledged, then every, because we are sharing the stages, so that for every stage delay we are getting one instruction out. Already we have seen, correct? I can say that in that scenario, for every stage delay, here what is the stage delay? Did they mention anything? We will see. So if you see this one, he has clearly mentioned that if each instruction takes one cycle time, each instruction takes one cycle to complete on average. Okay, that means what he is telling, that here your instructions takes exactly one cycle, but generally we know that it is one stage delay. But in the problem they said one cycle, that means each stage taking one cycle. Now from now onwards, each instruction takes only one cycle time. But unfortunately, because of unconditional instructions, sometimes there will be a penalty, extra penalty. Okay, we are focusing on that point. If there is no conditional branch, we will be very happy because your pipeline will be like this, correct? So that for every stage delay, example, this is one, already they have mentioned that every instruction is coming out after one cycle because they are taking only one clock cycle time, correct? So if that is the case, so each instruction is taking only effectively one clock cycle, right? But if it is conditional instruction, what happens, we'll see. If it is conditional, fetch, decode, execute, memory, write back, then rather than fetching here, we fetch here, correct? Then only we know the target. When you fetch here, then what is happening? What is normal? Normal is fetching here. Rather than fetching here, if you fetch here, then how many clock cycles you wasted, you see. So if you fetch here, then see, everywhere overlapping, correct? You can decode here, you can execute here, and you can do memory, you can do write back, right? So what I want to say is, if you fetch here, then obviously every instruction takes only one clock cycle, but you did not do that. What you did, you fetched here. So because of that, what is going to happen is, so here this place is empty, you wasted it, this place is empty. Because of that, if you see the timings, 1 2 3 4 5, the next instruction should take only one clock cycle, correct? But how much time it took? 6. That means rather than 6, memory, write back. See, 6 7 8, the next instruction came after 8 clock cycles instead of 6. That means 2 cycles we got extra in the instruction execution time. If you have so many such kind of conditional instruction, because of every conditional instruction you get extra 2 cycles penalty. So finally penalty is very important. Now how much penalty we are getting? Just 2 extra cycles, right? Now let us go to our problem again. What is the problem? Remaining problem. The processor stops fetching new instructions following a conditional branch until the branch outcome is known. Yes, fine, we understood that. A program executes 10 to the power of 9 instructions, out of which 20% are conditional branches. Fine. So I can say that out of all that instructions, whatever they said 10 power 9, you remember that 20% are conditional branches and 80% are normal instructions, right? Now, if each instruction takes one cycle to complete on average, the total execution time of the program is, he said that there are 20% conditional instructions, and we know the penalty of conditional instructions, 2 extra cycles. Okay, now we can solve this problem like this. 2 extra means what? They will have their own one cycle. Apart from that, 2 more extra cycles it is giving the penalty. Now we can use this formula for instruction execution time. See, all the instructions are having one clock delay, correct? One cycle time, remember it. Now I am calculating the average instruction execution time. It is one cycle time plus some penalty. How much penalty? The penalty is 2 extra clock cycles, right? 2 cycle times. But not, for every instruction do you have 2 extra penalty? No. For how many instructions? Only 20%, right? I can say like this. That's why 20% of time you are getting 2 extra cycles. Sir, what is this one cycle? It is the general penalty when you execute instructions in pipeline. So every instruction takes 1 cycle time, that is clearly mentioned in the question. So that's why 1 cycle. Apart from that, these 20% branch instructions are taking 2 more cycles. Then how many cycles an average instruction will take? 1 cycle plus 20% of 2 cycles. It will be 20 to the 40, 40 by 100, which is nothing but 1.4, I think, right? 1.4 cycles on average. Okay, so this is about cycle number of cycles, otherwise cycle time 1.4 cycles, right? But you want to know, if you see the question, in the question they are asking the total execution time. I want execution time. You have cycle time, you see clock cycle time 1 nanosecond, you have 1.4 cycles, then how much time they will take? 1.4 cycles, cycle time is nanosecond, then 1.4 nanosecond, it will become 1.4 nanosecond. But question is not about one instruction. Program has 10 to the power of 9 instructions. Then how much time they will take? 10 to the power of 9 instructions. Each instruction on average takes 1.4 cycles. Each cycle time nanosecond. So 1.4 nanosecond. It would become nano 10.9 cancel. It will become 1.4 seconds. That's why execution time is 1.4 second. Now we have another method. So don't get confused, because in some of the places you might see this formula. See how it is 80%, 20%. We can classify like this. 80% instructions are normal instructions, 20% instructions are conditional instructions. Let us do separately. So 80% of the instructions, if you see, they are not definitely branch instructions, then they will require only 1 clock cycle. Understand? Now 20% of the time they are branch instructions, they are having 1 clock cycle as usual plus 2 penalty, so 2 clock cycles. I can say that 20% of the time 3. So if you see 80% of, sir, what is this formula is for what? Average number of clock cycles required to execute one instruction, right? So 80% of the time 1 clock cycle, 20% of the time 3 clock cycles. If you use this formula, you get what? Average clock cycles, correct, for instruction. Then 80% of 1 clock cycle, so it will become 0.8. So I use 1 clock cycle is, let's say, x. The 1 clock cycle is x. Then 80% of x plus 20% of 1 into 2. If you simplify, 80% into x plus 20%, see this 1 plus 2, I can write 3x, correct? 1x plus 2x. Okay, if 1 clock cycle is x, 1 cycle plus 2 cycles is 1x plus 2x. Then 20% I can simplify like this, 20% into x plus 20% of 2x. Now 80 by 100 into x plus 20 by 100 into x is 100 by 100 into x. That's why it will become x. X is nothing but 1 clock cycle. I replace that again, 1 clock cycle plus 20% of the time 2x, 2 clock cycle. You get same formula. Understand? So there is no difference. Right? So this is the way you can answer this question at a problem, right? So one more way of solving this problem is like this. First of all, how many instructions you have? 10 to the power of 9, correct? So in 10 to the power of 9, 80% of the time you can do like this. 10 to the power of 9 instructions, out of them 80% of them are like this. In 10 to the power of 9, 20% of them is like this. So 10 to the power of 9 into 10 to the power of 9, out of them 80% instructions takes how much time? 1 clock cycle. 1 clock cycle means 1 nanosecond. Directly we can substitute 1 nanosecond plus 10 to the power of 9 instructions into, out of them 20% are branch. They take how much time? 1 clock cycle as it is plus 2 extra clock cycles penalty. So 3 clock cycles. Then each clock cycle takes 1 nanosecond. Then 3 clock cycles takes 3 nanosecond. Then if you simplify again, you get same answer, which is 1.4 second. Okay.